All right. This is 8th grade science. It's really close. Sorry. Um, and it is Instruments of Astronomy, 11.1, 11.2. I think I put on your stuff 11.2, but we really hadn't gone over 11.1 really well yet, but it's pretty easy. It's the telescope. So obviously astronomers use telescopes to study the heavens, to study anything that's out there in space. And on the big part of the telescope is the objective lens. You can see that at the bottom, page 338. And then the eyepiece is what you look through. And then there's two different types: reflecting, which uses mirrors, and refracting, which uses lenses. And if you remember, we talked about before, refraction is bending. So the lenses bend the light to be able to give it a clearer image and to be able to magnify the image in using lenses. And the mirror would be the reflecting telescope. So page 340 and 341 kind of just talk about the different types of telescopes. Make sure that you just kind of read over that. The larger the telescope, as far as the lens goes, the more light it lets in and the better it's going to be. But sometimes whenever we are down here on Earth looking up, it's really difficult to get through the atmospheric distortion. So the atmosphere kind of bends light itself, like through the clouds and water vapor and that kind of thing. And so astronomers wanted to figure out how in the world they could go beyond the atmosphere to be able to see things a little bit more clearly as to what's out there in space. The first way they did this was through adaptive optics, which is where they took these computer-controlled mirrors that would bend and flex and constantly to be able to correct the atmospheric distortion. And if you think of like taking a picture like continuously and like moving and flexing the light, bending the light around to where it could be a better picture. And a longest established way to avoid atmospheric distortion would be, it used to be like the telescope on a mountain or something like that line. They would get it up as high as they could. And then they realized that they could overcome distortion if they just could get above the atmosphere. So then they came up with the Hubble Space Telescope, and then that would be the best way for them to obviously be able to see above the atmosphere, because they are above the atmosphere. So there's a picture of Hubble, and there's a lot of things you can look up about the Hubble Space Telescope online, which is kind of fun to look at. And then they also use the spectroscope, which would be basically just another way that the spectroscope basically could bend light as well. It splits light into a spectrum for analysis, and so they use that in studying light and studying the different colors of light and that kind of thing. They also use radio telescopes like they have at Green Bank. And at Green Bank, if you haven't been to Green Bank Observatory, you should go. It's like 2.5 hours from here, and there's a picture of it on 344 in your book. But they use that, and they use interferometry, and basically where the radio telescope would send images of radio waves and images back to the laboratory, and they'd be able to look at things a little bit more clearly then as well. Page 342, 343, it talks a little bit about the electromagnetic spectrum. And you can see down at the bottom on 342, the electromagnetic spectrum. And the very far left there, it talks about radio waves, and they kind of put these electromagnetic waves, these are special waves that have electric properties and magnetic properties, and they don't need a medium. And the sun is one of the ways that they can kind of come down. So that is important because there's no air in space. So it doesn't travel through air, it doesn't travel through water, it can travel through anything. It doesn't have to, is what I mean to say. So, anyway, so they realized that these electromagnetic waves, all these different kinds, help us to be able to study the astronomy as well. So, the radio waves, they found those out, and they found those out there. Those are have the lowest of the frequencies and the like longer wavelengths. And then they came up with microwaves, and I think we've talked about that before. But there was a fella that was kind of playing around with the electromagnetic spectrum and studying it, and he had a chocolate bar in his pocket, and it melted the chocolate bar. So then he kind of accidentally studied, or he accidentally discovered radio or microwaves. Sorry, microwaves. Then you've got infrared rays, which are another type of electromagnetic radiation. And then you have visible light. So then they broke the visible light into a spectrum. And they looked at that, and it starts, red, orange, yellow, green, blue, violet. Roy G. Biv. And so that's why infrared was below. Infra means below, red. So infrared is below the red, just barely below the red. So we can only see a certain amount of these electromagnetic waves, and we see them as light: red, orange, yellow, green, blue, violet. And then above the violet, it's called ultraviolet. Above ultraviolet, above violet. So those are also electromagnetic waves, whichever one you want to say. And then you have X-rays, which are even farther up the spectrum. Gamma rays, even farther as well. So they range from lowest frequency to highest frequency, and they put those in. They realize they can just put them on that spectrum and study them that way. They will look at these little dark lines as you look at top page 343. They use a prism to be able to study visible light, but then they also use that spectroscope that we talked about before to study the visible light. Yeah, you can read all that. And that is pretty much 11.1. So I'm going to do a separate one for 11.2. I know that that's kind of not on your list, but you kind of have to have 11.1 in order to go to 11.2, and we hadn't gotten to that yet because of the craziness on Friday. So make sure you kind of look at 11.1 and 11.2 as well. And I'm going to do 11.2 next.